Good day to all. And uh, Jamia Islamia is organizing this architecture for masses, and the theme is architecture and planning for villages. My research topic is disaster resilient amphibious community houses. So the authors are Shuja Rehman, me myself, and Aftab Alam. And we have affiliations from Jamia Millia Islamia and Falah University. The keywords to the paper are amphibious houses, floating architecture, disaster resilient communities, self-sustainable floating houses, and the flood mitigation. So the question is, why floating architecture? The cost of reclamation of land, if we talk about that, why we are going floating in terms of that, then we compare it with the land, that the reclamation of land requires time as well as the expenditure. Floating structures are flexible and can be easily carried away in the distances, right? The floating structures are suitable for the deep sea. Structures are adjustable as per the water levels, and they are disaster prone, and can be modular and be implemented on the larger scale. Floating structures experiences basically six kind of forces. There are translation motions as well as the rotational. Three of them are translation motion, and the three of them are rotational. The surge sway he are the translation motions, and the whole pitch ye are the rotational motions. The mooring is very important for any floating structure to tie to the strata of the sea or the water body, which eventually balances these forces through the buoyant force and not to make it eccentric condition. When we talk about the mega float, there's this Japan airport which is being considered as a mega float. So there they used breakwater to have to lessen the water wave directly coming to the structure. They moved the structure and they gave the access from the floating structure to the land structure. So there are some of the literature review that we did over the floating communities. One of them is this aquatic architecture research article that has been done by Adam Musa, and this particular case is of Maldives. In the Maldives, there is increasingly high sea level rise, and eventually she tried to get into food, energy, water, education, and the housing for particular case in Maldives. Food she proposed as of for having seaweed, algae, lettuce, these type of food which could be floating in nature. Sustainable energy generation which could be floating, that is the wave energy, the solar energy, and even the algae biomass. The rainwater and desalinization. And further, she categorized the whole process into the phases, and she thinks that this is the phase two to adapt, that we need to develop adaptive module utilizing the existing city infrastructure, and also we need to see what else can be done. The next research I was able to understand, we were able to understand that the floating city, how floating city could move up, like in the middle image, blue one, you could see that a particular prototype can be moved from one place to another in case of disasters. If there's a cyclone in the city ocean, then eventually uh, the whole block can be moved to one particular area. And for categorizing into the modular thing, we need to see if that particular block or particular prototype is structurally stable, comfortable as per the wave characteristics of a sea or a river or a water body, and if that is movable and things like that. So this is a particular case study which we did for the Dhaka city. They particularly, this is kind of a very good example of a South Asian country with the local vernacular materials done, and they have this spine in the central image which shows that there is this stable spines, and then eventually the only the houses moves up and down, which we could see. This is comparatively a plan of that particular house community. Only two units were built there. This is the build plans and elevation of 2 units only. So the spine, which you could say from dark gray color, is fixed, and the light gray color moves up and down as per the water levels. On the left you could see the visuals of the floods and without the floods, and this is completely made up of the local materials, that is bamboo, the floating structure. Only the foundation is of ferrocement concrete. There are three types of species that are used for the bamboo. One is Baroque, Java, and Mulli. Baroque is basically used for the structural part. Java is used for exterior wall finishes and things like that. And Mulli is used for mats, for completely giving a very good look and things. This is the view of the particular uh, building, and they have tested two types of foundations. One is for the ferrocement, and the other is of water body, and they come up that the ferrocement foundation is more good as compared to water body, as there were some fluctuations in the density of that. What more important is that how they made this particular house self-sustainable. uh, for the water, they collected the rainwater, and then eventually through a very natural process of filtering, they gave a rainwater filter, and then eventually water is collected in a tank in the service line, which is fixed, and then this water is pumped up on the first floor by the people, and eventually people collects the water for drinking purposes. This only water is used by boiling it. And if you could see this diagram of rainwater harvesting storage systems, on the left, there is written biosense filter. This particularly used for reutilizing the gray water. The gray water comes into this sand filter. Biosand filters have basically three layers: one of sand and gravel, one of fine sand on top and coarse in the middle, and the gravel in the top bottom part of the layer. And water enters into the system from tops and passes through diffuser plate. And there are composite toilets where the units are diverted directly into the gardens that are truly collected for the biomass. They've used two solar panels, each one of 60 watt, and that particularly one solar panel is used for one household. And yeah, so this is another example of Netherlands, and for this particularly eco village, they have tried to use 30 water. There are almost 30 water plots. Each are being categorized as a group of six houses. So they try to give these 10 parameters, which include that should be collected to the urban area, that should be productive and thriving, that should be circular and sustainable, no wasted resources, produces more than it consumes, and that should be adaptable in architecture point of view, and it should be symbiotic with the nature, it should be inclusive of community, compact and connected, and should use nature-based technologies. So eventually they were able to create this and this was a very good example. These are the particular kinds of prototype housing that they made. So each house has been placed as a sustainable, self-reliant houses, and the more the energy that particular produces, if that energy is surplus, then eventually it is circulated to the nearby houses. And the jetty, which you could see, which connects all the houses, are a major service thing. And this is the plan of the particular housing and the different types of variability in the area. This is a complete scheme of a single house, which has a sun boiler, the green roofs to cut down the solar heat gain. There's this heat energy recovery system, and there is this wastewater system that is different, and so everything is connected into a particular house, and the jetty is being used as the carrier of gray and black water, and these are separated, and the biorefinery ferments the formation into energy. That's how they goes. So for the implementation part of design, it's a research which is oriented, design based. So The location of that particular implementation is of Tezpur, the rural area of Tezpur. Brahmaputra river is there and it swells every season. You can see the visuals of the flood, and it eventually goes up to almost 2 meters, 2.2 meters to be precise. And these is the parameters which we have studied to make it on a point. Like for the energy production, we are using piezoelectric, solar panels, wind funnels, and also the biomass. And yeah, for water management, we are utilizing rainwater and wastewater. For there's a food production area also. The structure is ferrocement and the local material, which is bamboo, and the local materials is there, which is derived from the stability along with the materials. So this is the visual of a house which have a white portion, which is a floating foundation. There is this entry, and there's a small garden or agriculture area where they could increase it, and then eventually has to be tested for the structures. And the central spine, which you could see, the huge bamboo structure, it's a central spine which is fixed to the ground, and the whole other houses moves up and down. So there's a cluster of 8 units, each have 5 members. So it cumulatively makes 40 people, and it has piezoelectric panels on the top of the spine, along with the solar panels. That is actually solar panels with the piezoelectric material, so that if a raindrop falls, then eventually it converts the mechanical energy of raindrop into electrical energy. It has a wind funnel in between, which sucks the air and passes through a small area, sucks the wind from the more area, and it goes to the smaller area, which is eventually effect, or even V1 is equal to A2, and then eventually more energy can be harnessed from that particular thing. These have shared areas of water, of sanitation, and also for the agriculture. So this is a schematic section of this particular house, which have in downward they have this living area, and on the above they have kitchen and washrooms, and from the washrooms the urine is particularly directed to the gardens, and the stool is collected below in the foundation, and also the grey water is collected in within the foundation project, sorry, tank. uh, Rainwater catchment area is above the spine only. The above surface is collect the water and makes it down and stored in the particular two tanks of either side, and then eventually these tanks, from these tanks the water is pumped out. And yeah, so during the flood, it's like this: the whole houses goes up, and it comes down during the normal days or as the water resides. So these are some visuals of the house, which shows the materials that are used: bamboo, and these are some calculations of water. Like for a rural area, water requirements is 55 liters per day, and with a 40 population, we get 2200 as the total cumulative water requirement. The below table shows that there is a breakage of uh, water, that for drinking we use 4 LPD per person, for cooking 11, bathing 15, washing utensils it's almost 10, and ablution is 15. So the water breakage is almost 55. For if So how about the renewable resources that we are able to gain the water? First is the rainwater harvesting, which eventually per day, with the coefficient and area, catchment area and annual rainfall, we almost get 1479 per day. And gray water we get from the laundry almost about 1600. So the urine from the toilet is directly used in the gardens. We are not taking that into account. So total renewable water is around 3160 liters per day. And for that particular day, if we cancel out the 2200 of the water requirements, and eventually we get 960 liters per day, that could be able to grow almost 160 kilo rice. Yeah. Energy requirements for a particular house, we have calculated a cumulative energy. We would be having a fan, a table fan, two tube lights, two bulbs, and a TV, mobile charger. So it comes out to be 2.08 kilowatt per day. For 8 units, we need 16.64. So this is the total energy requirement of a house, of sorry, building with 8 units. That comes out to be 16.64. So how will make it net zero? We are taking the solar panels, which is of 325 watt, and will be able to get 60 solar panels as per the size over the top of the spine, and it will eventually be generating 19.5 kilowatt hour. And yeah, we will also be using some piezoelectric and internal energies. These are some radiation map analysis for a particular uh, this particular house. And also on the right top, you could see there's some analysis for uh, top of this spine, which says that on a mean radiation there is 1436 kilowatt per square meters energy is there. So it supports that the sun energy can be used. The storage of batteries and everything will be in the central spine with the uh, waterproof drums. This is waste generation that a human excreta can be used, uh, which is almost about 11.68 cubic meters per year. These are some options of the farming. For the structures, if we take say that how the bamboo should be treated, the bamboo treatment is very necessary to make the life of the building more and also make this building feasible. So with the treatment of boron, it almost internal bamboos can go more than 30 years, and treatment with the fixed preservatives and that can also be used, which eventually increases the life of external bamboos which are in the ground or above the ground. So these are the references which are already in the literature reviews and everything. Thank you.